This Zoom session has been brought to you by the Fractal Almond Bullseye Horizon. All right, let's see. I believe today we start with chapter 4, and I'd like to do 3 sections today, so that Tuesday we finish the chapter. These are really of a unified theme, so that's why I'd like to do it that way. All right, as you can see, this is a relatively short one. This section is about solving linear systems by graphing. A 2x2 linear system is of the form ax plus by equals e and cx plus dy equals f. For a, b, c, and d, e, and f, constant, and x and y, the variables unknown. For example, here are 2 numbers, x and y, whose sum is 10 and whose difference is 4. What are the numbers? Well, okay, 7 plus 3 is 10, 7 minus 3 is 4, so 7 by 3 is a solution of this system. Now, if you graph x plus y equals 10, you get this line here on the plane. If you graph x minus y equals 4, you get this line here. These 2 lines meet at a single point. Of course, it's 7 by 3. So 7 by 3 is the solution of the system, and it's the intersection of the graphs of the lines. Now, okay, there are also systems which graphs as parallel lines. Here's x plus y equals 10 with this graph here, and x plus y equals 4 with this graph here. They're parallel lines, so they do not intersect, and that should make sense because there's no solution of the system. Poor x plus y is trying to be 2 things at once. So no solution exists, and that's what parallel lines mean. No solution means the graphs are parallel lines. Here we have the system x plus y equals 10 and 2x plus 2y equals 20. These are equivalent equations, so they graph as the same line, overlapping lines. You can say they intersect along their entire length. Since really these are only these are 2 equations, well, sorry, these are 2 variables, but there's only 1 equation's worth of information. There's not enough information to determine x and y. So many solutions exist. That's what overlapping lines mean, many solutions. Okay. All right, so here's an example, x plus y equals 10, x minus y equals 4. 2 intersecting lines, 1 solution. Here's a system whose graph is 2 parallel lines and no solution. Here's a system whose graph is overlapping lines, many solutions. Now, there's a problem. Sometimes people use the word infinity or infinite in describing both of these 2 systems, and it's ambiguous. So you can say that when we get to giving numerical solutions to these systems, you could say that this is a solution where the solution is at infinity, where x and y are off at infinity, parallel lines meeting off at the horizon. Or here we can say that there are infinitely many solutions. Please don't confuse these. I've lost track of the number of times people would say infinite solutions, and that's ambiguous. Infinite solution, does it mean that the solution equals infinity, or there are infinitely many solutions? That's ambiguous, and in mathematics, ambiguity is not your friend. It is your friend in love and war, but that's because mathematics has standards. So, okay. All right, well, I do believe that's it for this one.